Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use derivative rules to find the slope of the tangent. So as per the problem, determine the slope of the tangent to each of the curves at the given point. So let's start with part A. So in part A, we are given the equation of the curve as y equals 3 times x to the power 4. So the first step is to find the derivative of this function. So as you may know, the derivative of the function represents the slope of the tangent to that function. So we can use either the Leibniz notation or the prime notation. So for this one, we can use the prime notation. So we'll write y prime equals the derivative of 3 times x to the power 4 over dx. Now we can use the constant product rule to find the derivative of this term. So as per that rule, so we'll move the 3 out of the expression and we'll put it in the front. So it'll be the derivative of x to the power 4 over dx. So now we can use the power rule. So as per the power rule will move the exponent to the front of the term. So 3 times 4 and then x to the power 4 minus 1. So we subtract the 1 from the exponent. So now we can simplify this term. So 3 times 4 is 12 and then x to the power 3. Now we have to find the slope of the tangent at the given point, and in part A the given point is 1 comma 3. So we'll have to sub in x as 1 in this derivative expression to find the slope of the tangent. So we get y prime equals 12 times 1 exponent 3. Now 1 to the power 3 is equal to 1. So therefore we get 12 times 1, which is equal to 12. So this is the slope of the tangent. So we can write our answer as m equals 12. So this is the slope of the tangent for part A. So now we can analyze part B. So we are given the equation of the curve as y equals 1 over x to the power negative 5. Now in this expression, the coefficient of the x is, the exponent of the x is a negative number, negative 5, and x is in the denominator. So the first step is to simplify the expression by moving the x term to the numerator and making the exponent positive. So this is the equation we should use to find the slope of the tangent. So we can use the prime notation, or we can also just write it as m equals the derivative of x exponent 5 over dx. Now we can use the power rule to find the derivative. So we'll bring the exponent to the front, so 5, and then we'll subtract 1 from the exponent. So we get m equals 5x exponent 4. Now in part B, we have to find the slope of the tangent at negative 1, and the x coordinate in this point is negative 1. So we'll sub in x as negative 1 in this expression. So 5 times negative 1 to the power 4. So now we can simplify this expression. So negative 1 to the power 4 is 1. So times 5 is just 5. So the slope of the tangent at the given point for part B is 5. So now we can analyze part C. So for part C, so in part C we are given a rational function. So the x term is in the denominator. Now in order to find the derivative of this function, we'll have to move this x term to the numerator of this fraction. So we'll rewrite this as y equals 2 times x exponent -1. And now we can find the derivative. So the derivative will represent the slope of the tangent. So m is the derivative of 2x exponent -1 over dx. Now here we can use the constant product rule. So we can move the 2 to the front. So it will become derivative of x exponent -1 over dx. Now we can use the power rule. So we'll move this exponent -1 to the front. So 2 times -1, and we'll subtract 1 from the exponent. So we get m equals, so 2 times -1 is 2, x exponent -2. And in the next step, we can move x to the denominator to make the exponent on it positive. So m equals -2 over x squared. Now we have to find the slope of the tangent at point -2, -1. So we should sub in x as -2. So we get m equals -2 over -2 squared. Now we can simplify this expression. So we get -2 over 4, which can be reduced to just -1 over 2. So this is the slope of the tangent for part C. So now we can analyze part D. So in part D, we are given a square root function. So the first step here is to change that square root to a rational exponent, which will be equal to 1 over 2. So we'll write 16 and then x cubed and then exponent 1 over 2. Now in the next step, we can distribute this exponent 1 over 2 to 16 and x cubed. So we get 16 exponent 1 over 2 and then x cubed and then outer exponent 1 over 2. Now since the rational exponent 1 over 2 represents square root, the square root of 16 is 4. And then for x, we can use the power on a power law of exponent. And we multiply the exponents 3 and 1 over 2. So we get 3 over 2. So 3 times 1 over 2 is equal to 3 over 2. So we should find the derivative of this expression. So we have to find the y prime, which also represents the slope of the tangent. So m equals, so the derivative of 4 and then x exponent 3 over 2. Now we can use the constant product rule. So we can move the 4 outside the expression. So we get 4 and then derivative of x exponent 3 over 2. And now we can use the power rule. So we get m equals 4. So we'll multiply 4 by 3 over 2 and then we'll subtract 1 from the exponent. So 3 over 2 minus 1. So we get m equals, so 4 times 3 over 2 is equal to 6, because we can reduce by the 4 and the 2. So we get 3 times 2 over 1, which is equal to 6. And we get x. And now in the exponent, 3 over 2 minus 1 is equal to 1 over 2. So this is the expression for the slope of the tangent. Now we can sub in x as 4 because we have to find the slope of the tangent at a specific point. So we get m equals 6 and then 4 exponent half. So exponent half represents square root. So square root of 4 is 2. So we get 6 times 2, which is equal to 12. So 6 times 2 is 12. So this is the slope of the tangent to this curve at point 4, 32. So these are the steps you have to keep in mind to find the slope of the tangent to these curves at the given point. So the slope of the tangent is the derivative of the equation for the curve, and then we sub in the appropriate or the given x value to find the value of the slope of the tangent at the given point. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.